A get? What does B get? All right, so A is the 40 plus 90 plus 60, which is 190. B is 120 plus 50 plus 100, which is 270. Yeah, so B wins. B gets a point. And then we do A versus C. Now, did you already do this?
Yeah.
Okay, and
So
so
what
so
I got was A versus C is 290 to 170, and A gets 1 point. A versus D is 200 to 260. D gets 1 point. C versus B is 270 to 190. So C gets 1 point. C versus D is 260 to 200. C gets 1 point. B versus D 140 to 320. D gets 1 point. And so D and C both have 2
yeah.
points.
So to answer your question, there is so it's between C and D, and there is no winner using this method.
Okay. I was just trying to figure that out because I wasn't really sure.
Yeah.
I never did ones that tied.
Right.
Did other ones that all matched up perfectly.
Yeah. And I mean, these are I mean, somewhat interesting from that perspective, that you could have a voting method where there's ties, because the whole point is to declare a winner in most cases.
Yep.
Okay, so is 6 the same question?
Yeah, I got a tie with that one also. So
Do you, I mean, so did like when I was running through it, I mean, like, I think your numbers are right, but I mean, is it possible any of them were off? I mean, it is kind of a lot to go through.
Yeah, I double checked them.
Okay.
I was just putting the things in, and my calculator this time I wrote each one out. I was adding the things on my paper.
Okay.
So I'm pretty sure that I got all the numbers right.
Got it. Okay. So does that take our 6F then also? Because
Yeah.
it's the same thing. All right.
So 9 and 10, I'm confused. I don't know if you know anything about the Cordec candidate.
I'll look. I mean, I will look and get you an answer here in the next couple minutes.
Okay.
So no notes on this.
No, not really. No.
Okay. All right. Well, the internet's kind of a wonderful thing in some ways, where you can find a lot of information pretty quickly. All right. So it looks like you do an A versus B, ignoring C, a B versus C, ignoring A, and then an A versus C, ignoring B.
Okay.
Okay. Now, that sounds really similar to what we just did, though.
Yeah. But it has a completely different name. That's the hard part.
So let me, I mean, that's just my first kind of resource that I'm finding. Set candidate math example. What was like examples? Is an election consisting of 5 voters, 3 alternatives, which 3 voters for A to B, B to C. Okay. All right. So we go first, second, R, H, 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 R, R. H versus R. R, H, H. But what does that give us for numbers? If we compare just H and R, 49 people prefer. 51 prefer H to R. But where are those numbers coming from? Oh, I see. Okay. So again, kind of very similar. So it's you look at, like, let's say you compare A versus B. We'll do that first. So in the first column, 14 people prefer A to B.
Okay.
In the second column, 15 people prefer B to A because it's
Mhm.
above. And then in the third column, 2 prefer B to A. So B wins.
Okay.
All right. And then we do the same thing now for A to C. So let me grab the snip the table here. Okay, so now A versus C, you got 14 in the first column, 15 in the second, and then 2 in the third. And so C wins.
Mhm.
So A is not really in play here. So it looks like it comes down to B versus C.
Right.
And we can see that B gets 14, C gets 15, but B gets 2. So B wins.
Okay.
So it's like B beat A and B beat C. So B wins. All right, so let's look at 10.
Okay.
Or to organize this a little bit more. ASU has a ASU one of the Rio Salado, they have a class where this is always the last chapter, and I get a lot of calls for this. So all right, so A versus B. So 8 prefer A, 7 prefer B, and 6 prefer B again. So B wins.
Mhm.
And again, these are column comparisons. Always going down the column. So now we'll do A versus C. Is that what we did next? Yeah, we did A versus C. Although you could make the case, well, why would you check? Since B won, you probably should just go right to B versus C to see if it wins. But I don't know. We'll just keep going here. A wins, C wins, C wins. So C wins. And then B versus C again. So B wins, C wins, and B wins. So B wins again.
Okay. Does the voting system have a conductorate candidate? If so, find it. So both of these have a,
It would appear to be B in both cases.
yeah. Okay.
And actually it's like if you look at the tables, the numbers bear that out as well, because the positions of all the letters are the same in both 9 and 10. Just the numbers at the top are the same. So that's reasonable.
Okay.
All right, so for number 11, do you have a list of fairness criterias?
No, I don't remember him going over that in the videos.
Might have been a PowerPoint slide deck thing. You can read this again here. It says an election results in candidate A winning and candidate B coming in close second and candidate C being a distant third. If for some reason the election had to be held again, C decided to drop out of the election, which caused B to be the winner, which is the primary fairness criterion violated in this collection. So the like just for some simple numbers here, let's say we see this actually all the time. Actually, this happened in Georgia very recently in the Senate. A got like 49%, B gets 48%, and C gets 3%. And the idea is if you combine that to With B, then they would now have 51. So A wins against B. B's a close second, but C is really not in the race at all.
Okay.
But they're saying, well, what is the fairness criteria that is being violated here? And I guess one would be,
Okay, I think I found it in the notes.
I mean, to me, it's the fact that the A one with the majority.
Right.
That would be my guess, because A1 doesn't matter. Doesn't matter what C, but is that okay, or do you want more explanation on that?
I'm still kind of confused.
Okay. So the idea here is that if you believe that elections are won with majority,
Mhm.
then it doesn't matter if majority means that you only need one more vote than anyone else.
Okay.
Okay. And again, like the smaller the numbers, maybe easier. Like let's say Emma gets 10 votes and Matthew, he got 9 votes.
Right.
You win. By majority, you win, because
Mhm.
everyone else here, let's say your brother, let's say he got 3 votes. Say dad got 2 votes, and the person down the street got 2 votes. Like, you don't care. You don't. This should be irrelevant
Right.
because you got 10 votes.
Mhm.
And like I was shocked at this, but I had a government teacher tell me a long time ago, people vote in like Mickey Mouse for president every year or every 4 years. And you're like, why would they do that? And you're like, I don't know. It doesn't matter. But the person with the most votes wins. Now in the presidential race, it's not the most votes, but in a majority rule, it doesn't matter. You don't get a second vote. You don't. And this is what's called they call it a runoff when you go back to 2 candidates.
Right.
And that shouldn't matter. Which makes you wonder, this is an aside here, why you don't just have a runoff to begin with.
Yeah, I don't know. So
But
weird.
that's a different class. That's a government class.
Yeah.
So the majority rule is what's being violated, because it shouldn't matter like if these people are out and we get to revote, because when you revote, a lot of things could happen. Because they're not at the time of the vote, they're not saying like now also over here decide, if it's just these two, because they don't know. They don't know that it's just those two.
Right.
So there's no way to do it without implementing bias into the vote.
Okay. So what I'm getting, the answer is election A, B, which is fairness. What's the fairness of game?
So this is where I don't know. I mean, I'm just talking about the majority.
Yeah.
This is one of those where you got to check your notes or ask the teacher, am I on the right track here? Or
I see there's a video I missed on this. I did upload it, apparently not. It's not even math, they just want sentences. I hate that kind of math. Give me numbers. Okay.
So
Uh,
number 12, I don't know if you're ready to move on to that or not.
yeah.
Number 12 like looks really similar, but it's kind of awkward. So
Mhm.
we'll read it again. It says an election resulted in candidate A winning, with candidate B being coming in a close second, okay? And
Mhm.
candidate C being in a distant third. So it sounds very much the same as what we just saw. But this time they're saying that if for some reason the election will be held again and many people had voted for C, switch to A. So the people who switched to A went to A, B now is the winner, which is weird. It's like, well, you would think it would go to the one that they switched their vote to.
Right.
Okay, so this I believe is what we were just studying, which is the Condorcet. What is it? What was it called here? Condorcet candidate.
Okay.
And it would take some numbers to get this to come out right. But it's the same idea. You got what did we have in the, you have number of votes, first choice, second, and then third. And we just have to come up with the numbers here, if that's part of this, which maybe it is. So let's see here. I mean, maybe we just reuse the numbers that we had before. So 8, 7, and 6. Which I'm not sure, because I thought the numbers here would change, but like we know that, and we know when we did this before, B won in both of these.
Yeah.
So the idea here is that B still wins, but how? That's what I'm
Right.
struggling. That's what I'm saying. Because if the C switches to A,
They should win.
well, you would think that more votes would, but maybe it's not enough.
True.
You know, maybe it's like, maybe this just changes to 9. Let me grab this table and see if we can get this, you know, maybe that just makes it 9 there. And then you know, B, so C in the second, one here, B is still more than A. So even the C switching to A, we would presume would still make that the winner.
Right.
And we presume that that's still the winner there, which is why.
Oh, I see, because it's still 2-1.
Yeah. So that might be your justification. I'm out. I don't know. That's great, but maybe it's enough.
Right. I get it.
Again, I'm not sure. I'm really not sure. These are tough.
Yeah.
You know, we don't have much in the way of you know, like real life experience with these.
No, because not many people go and they calculate votes and stuff. There's a whole group of people for that.
Yeah, it's not us. So I'm running out. I'm seeing, you know, another one of
Yeah.
these, and I mean, these are guesses, full
I get
disclosure. So I don't know, you know, I want to say it's going to be another voting method down, you know, in this.
right.
So let's see here. Unless this is the Condorcet. So head-to-head comparison. So this one again, C, can't A winning, B is close second, C is just third. If in a head-to-head comparison, a majority of people prefer B to A or C, which is the primary fairness criteria violated? See, that sounds like majority rule. Did it not say that in one of these other ones? Oh, this one's drop out of the winner. Okay, maybe this one is majority rule.
Right, I think each of them have a different voting
Yeah,
technique or whatever being, and they're trying to say what's unfairness about it.
so
Maybe.
so 14 talks about a majority of first place votes. So one of the methods must talk about a majority of first place votes.
Mhm.
And that's the plurality, you want to say, maybe?
Yes, it is. It's
Okay.
plurality.
So, I'm gonna go plurality with that one. Now maybe it's getting a little bit clear here. So
Yeah, it's a
13,
little better.
I mean, 13 head to head wasn't, I thought that was, so the head to head is either the conduit or it's that one we did to start out the, I didn't get the name. Let me go back and look at your other document.
Copeland's method.
The Copeland's method.
Copeland's method.
But what's the difference between Copeland's method? So it feels like one of them, the candidate drops out.
Yeah, I'm trying to figure out which one that is.
So just to be clear, I guess I'm going to switch my vote to majority rule for 13.
Uh-huh.
But then we got to figure out between Condorcet and Copeland's method dropouts.
Yeah. Which one drops out? Is that the board of count method?
Or board, yeah.
Board of count, you take away the least amount. So I think.
Well, that sounds like it could be this one here. Pair of candidates. So in Copeland's method, they're all pairwise comparisons are made. So that doesn't seem right.
Okay, board of count, if a choice has majority of first place votes, that choice would be the winner.
Did you at all hear about a spoiler effect?
No.
Okay.
Runoff vote is if voters there increase their preference for a candidate, it should not harm the candidate. That's not the same. That's a word I can't pronounce. One-to-one comparison. Hand-to-hand comparison.
Okay.
Okay, can we go to the other document?
Yes. All right, so this is the
Completely different other assignment that was due this week.
all right.
So we have a discussion board and we're supposed to post our questions about the thing and stuff. And people are supposed to help us, but they don't help. And they're like, this is so easy. This was so fun to do. And I'm like, well, how did you do it? And I was like, oh, what kind of calculations did you use? And they're like, any calculations will work. And I'm like, well, that doesn't help either.
Yeah. Well,
Wow.
there's a Yeah, there's a way, I guess, to do this that you got to know where to start. And I mean, once I show you where to start, so we're gonna call this square x and x.
Okay.
Okay, so we're gonna make a yellow and a red. Actually, I'm gonna do a column as a column. So the area of the yellow so far is x squared.
Okay.
Okay. Now in this semicircle that's in red, the radius is this length here that I've just drawn in. Do you see that?
Yes, I do.
But it's also this, which is important. So that is x divided by 2.
Okay.
So I may want to, I know fractions aren't great, but I will hold on to that for a moment. Probably could have done it differently. So the red, there's actually, you count them both. So there's a circle.
Uh-huh.
The two of them make up circle. So it's pi r squared, which is x over 2 squared.
Okay.
So we've taken care of those three.
Mhm.
Now the next yellow, kind of this region here and the one here and
Yeah.
one here, it's a subtraction. It's the area of the whole square, subtracting out the circle and subtracting out the other one.
Uh-huh.
So to do that, its base is x over 2 plus x, which is 3 over 2x times 3 over 2x, so 3 over 2x squared. That's the big one. Is that clear?
Yeah, I see.
Okay. Minus the circle pi x over 2 squared minus the other yellow. Now, you may notice that if you were to, you may notice that this x squared and this minus x were, excuse me, they cancel out when we add these up, because we're gonna add all these up, but we're not quite ready for that.
Right. Okay.
Okay, now we got to find the area of the red here, these two circles.
Uh-huh.
Okay, and based on what we have here, but this length right here is 3 over 2x going across. That's the diameter. Maybe we can write that in here. The diameter is 3 over 2x. So if you cut that in half for the radius, it's 3/4 x. So the radius of this big one is 3 over 4x. Now I know the variables aren't great. We could have used numbers, but we didn't know. If I need to, I can do that again with numbers. But it's pi 3 over 4x squared, like that. So now our last region is this yellow over here on the left, this yellow over here.
Mhm.
So to get that, you need the full width here, 3/4 x, excuse me, and 3/4 x. You have to add those up. So that's 5 over 4, 7 over 4x, I want to say. Looks right. So the yellow is 7 over 4x squared. That's the outside one.
Okay.
Okay. And then you subtract this red and this red, which is the pi 3 over 4x squared.
Uh-huh.
Okay. And then this is where actually I need to step back in here and think a moment. That gives us so that gives us everything but this square here,
Okay.
because it's the whole one, subtract out the two circles. So then we know that, be careful here, the I don't want to do this. I almost feel like it'd be better to go to numbers at this point,
Okay.
but we can finish off. So we have to subtract out from this last one.
Mhm.
Okay. We don't need that anymore. We can get rid of that. We have to subtract out then the this yellow square, which is 3/2 x squared. And that takes care of this. That takes care of this one here. Actually, I didn't need that. All right. But what you ultimately want is numbers. And that's probably so. The reason we did this, and I should have probably made this clear, is we need a number that we can cut in half and then take 3/4 of it.
Okay.
Okay. And there's many numbers that do that, but let's not pick one that's too large here. So let's try this again with numbers.
Okay.
So this, we'll call this 20 and 20. All right. And then that's for the square. So then the circle here, its radius is half. So its radius is 10. Half of the 20. Is that okay?
Yeah, I get that.
Okay. So that's good. And then this big length is 30.
Oh yeah, okay.
Which means that you can come up here to this circle's diameter is 30. So that makes this 15.
Mhm.
Or this one's 15 if you prefer, because it's the same as this. So the whole thing is 45.
Okay.
So we can now do this. We can now do this in pieces. So the red is the easiest to do. So let's do the red first.
Mhm.
Red is the larger circle, pi 15 squared. The smaller circle, pi 10 squared. And now I see three squares. There's the small one, the medium one, and then the large one.
Yeah.
So let's do the small square first. So this is now yellow. Actually, let me do it over off to the side. Okay. So the small yellow is 20 squared.
Okay.
It's the small one. The medium one is 30 squared minus. So we have to
Okay.
subtract the two circles and then subtract this square.
Oh, okay.
So minus the pi 10 squared minus the 20 squared. And then the large yellow is 45 squared minus the large circle, which is pi 15 squared, minus just the, like, think of this square as you don't care what's going on in there.
Mhm.
So it's the medium square.
Right.
Just the medium square though. So it's minus the 30 squared.
Mhm. Got it.
Okay, now in terms of numerical value, so we want the oh, total yellow to, okay, so all right, so the total red is, we just had this here, 225 pi plus 100 pi. So it's 325 pi, which is it's around 1100-ish, right in there. And we'll calculate exactly. But then the yellow the yellow appears bigger, but because you're subtracting out stuff, so it's the 20 squared, the 400
Mhm.
plus the 900 minus 100 pi minus 400 plus the 45 squared, which I don't know, minus the 225 pi minus the 900.
Well, yellow's a lot more complicated than red.
Yeah. But because the regions aren't as nice. So I'm going to my Desmos Scientific. 325 pi is about 1021. The yellow is 400 plus 900 minus 400. All right, this ends up being 1004-ish, 1004.
Okay. So the red is bigger. Which area is
Yes.
bigger than the total? Just 5 combination of pick one, yeah. Read that. My page looks like a mess, but it is a mess
Yeah.
with a solution.
Right. Right. So, but the problem is we have artificially assigned numbers. Like we don't actually know how big the yellow is.
Right.
So the correct way to do it is to build a ratio and show that the ratio is bigger than 1. But for probably what you're doing, it's good. It's okay to do this.
Mhm.
But the ratio of red to yellow would be bigger than 1. But requires some pretty complicated algebra to show that.
It's supposed to be an easy class.
Based on what I've seen through 2 lessons with you, I disagree. I mean,
Yeah. It's supposed to be the easiest math class you can take in college. I'm like,
wow.
there should be an easier one for this.
Yeah, I mean, a lot of students have that one, they're getting let's just say a Bachelor of Arts in something, and they're like, yeah, I got to take one class. This is the kind of stuff that they have to take, and it's tough for them.
I'm like, "Oh, math."
Yeah. Okay. We got some time left here. What else can we do?
That was kind of it.
Okay. I'll spend just another minute or two here looking for those problems there, that the 11, 12.
Yeah, 13, 14. Yeah, okay. I appreciate that. It's just so if you did it, maybe I can look more into it. So I didn't realize those ones. There were problems, so I was like, you can help me with that.
Yeah.
Word problems, they just overwhelm me.
Yes. So here are some fairness criteria that I found. These might be worth looking into. When is this assignment due?
Tomorrow.
Tomorrow, of course, Sunday. Yeah, I mean, teachers do have emails that they'll check on weekends, so give that a look.
Mhm.
Maybe send over some.
Are you still there, Matt?
Yes.
Okay, sorry.
If B is, which is the primary. If B had received majority of first place votes. So was there one with first place votes?
Oh, yeah.
So the answer I've seen a couple of times here for this one is monotonicity. But if you haven't covered it, I mean, it's very, you gotta be very careful putting in words that are not covered in class, because then they wonder where you got them. That
Yeah,
could create you more issues
I understand.
than it's worth.
Majority of first place votes. Head to head comparison of majority. Switched preferences. And dropped out.
So the dropped out feels like it's Condorcet.
Oh, I see the Dorset candidate or whatever that was.
So for 12, yeah, I'm seeing Condorcet for this one
Okay.
a couple of times. With kind of related questions, just but boy, I don't feel great about that. No. See if there's anything else here. So I'm gonna say, here's my final. I'm gonna say the first one is monotonicity. Monotonicity. The second one is the Condorcet. So maybe make these more clear.
Okay.
And then majority rule, plurality. But the thing I keep seeing over and over again for these is these four.
Yeah. Okay.
So I don't know. I don't know if that could play in. But yeah, that's probably it for us for today. Thanks